on page 15 of our notes packet. So open up to page 15. It is. But when it comes to these problems, generally a proof, I tend to give you lots of extra room. So I always try to give you at least half a page to do a proof, even if it's not going to take half a page. Because some people write obnoxiously big. Okay. So, today we're officially getting into actually doing proofs. Now, a proof is similar in idea to the problems that we did with the algebra where we stated the math and justified it. So, it's going to look kind of similar, but when it comes to proofs, there's technically a lot more involved than just doing algebra. And to make life easier on ourselves, generally, I've found that in the proofs that we do in this class anyway, there's 5 things to kind of go through and look for in your proof that tell you what to do next. The first of those 5 things that I want you to look for is words. In a math class, words tend to stand out, so we look for words first. Because if you see words in your proof, you have an entire section on your orange sheet that says things that you get from words. And we use that to our advantage. The next thing we look for is symbols. When I say symbols, I mean like congruent symbols, or a symbol that looks like that. Does anyone know what that symbol is called? We're on page 15 of the notes packet. Thank you. Does anyone know what the symbol is called?
Where's your fan? It's really hot in here.
It's cold in here.
It's hot in here.
Oh my god, it's cold.
No, I'm like, I'm dying. I'm in sweatpants.
It's humid in here. That's the thing.
It is cold.
It's hot in here.
But that being said, the fan is not going to help it that quickly. So anyway, we're going to get back to the math. That symbol, you should have seen it before. Starts with a P.
Pi.
It's not pi. Nice try. It's perpendicular. It's been a minute since you've seen it, so if you don't remember it, it's not the end of the world. And there's also a symbol that looks like this. It's the parallel symbol. Okay, so we look for words, we look for symbols. We look for algebra. If you've got equations that you know how to solve, we just do some algebra with it. We look for substitution or transitive property. Now, substitution and transitive property, these ones happen generally when you see 2 of the same thing. Or you need to plug something in. And we'll get a little bit more talking about that when that comes up. The last thing that you look for in a proof to kind of give you hints on where to go next is pictures. And we look at pictures last because pictures tends to actually be the least helpful of the options, even though they will actually pop up a lot. They're limited on what they can do though. Now we look for these 5 things in a proof just to kind of help us with figuring out where to go next. So you're going to hear me refer back to these 5 things a lot. But as you get more and more used to the proofs, generally a lot of people stop having to ask themselves about these 5 things because it directly leads to, they start to get the pattern of how these proofs work. If you are not that person, it is not the end of the world. You can always ask about these 5 things. In fact, you will find that on the top of your orange sheet, there is a place to put the 5 things. I am not going to write in that section right this second. You may during work time. I would not recommend you doing it right now because I want you to see the main proofs. I don't want you to lose track of where we're at. Now, when it comes to proofs, anytime you see given and prove, we are going to do what are known as 2-column proofs. So, you're going to see me draw a line down the middle, and then there's a line on top that really just kind of holds the names of the things that go into proofs. Proofs are made up of 2 things: statements and reasons. And so the titles that go on these columns are always going to be statements going on the left and reasons going on the right. That being said, most people shorten them just to an S and an R, and I am okay with that. Now, statements is the actual math. It's the steps that you do. Reasons are how you know you can do that. Now, when it comes to our proofs, in order to help us line things up, another thing that we're going to do is we're going to number our statements and their corresponding reasons. So both sides are going to start with the number 1 because we're going to do the first thing. And every single proof, regardless of the proof, starts with the given. So our first reason is always going to be given. And our first statement is always going to be the stuff that's written under given. Kj equals 2x plus 16. Now I tend to move to a separate line rather than separate things with commas. That's a personal preference. I think it's easier to see things. Ji equals 6. And Ki is equal to x plus 15. You should always be able to get that part of a proof. Free points on tests and quizzes by just writing down the given and the word given. After that, we start going through our 5 things. And when I go through the 5 things, I'm specifically looking here with one exception. Okay, so I look here at the stuff that I have in my proof. Are there any words in this stuff right here? No, so we move on. Are there any symbols like congruent, perpendicular, or parallel?
No.
No, moving on. Can I do any algebra with this right now? I actually can't. Algebra would require an equation be written where it's all a normal equation like. It would require me seeing something like 2x plus 7 minus 3x equals 14. Do we have an equation like that? No. Everything, all of my expressions are equal to letters. And these we don't solve with, so there's no algebra yet. Substitution or transitive property would be the next thing I look for. So I look at the names specifically. I look at the letter piece and I try to ask myself, is the same thing popping up twice? My letter piece, I've got KJ, JI, and KI. Are any of those the same? No, so I don't have that. And that's where the 5th thing comes in, and the 5th thing is a picture. On your orange sheet, do you notice that there is a section that says the information you'll get from diagrams, aka pictures? Is it on the front of the sheet or on the back of the sheet, those who find it? On the back, the very top. There are only 2 things you can get from pictures: segment addition postulate and angle addition postulate. The question is, does this picture look like either of these? Which one? Segment addition postulate. Since that picture looks like this, I can use the segment addition postulate. The reason is segment addition postulate, which we shorten down to seg add post. The actual thing we write in the proof, the orange sheet, says I can write out the things added together in letters, not in algebra, in letters. I can write out this version. So that version starts with this. What's this thing's name?
KJ.
KJ. And then it says to add this part. JI. And it says I can make it equal to the big thing all the way across. KI. Once you write that out, that step is done. And then I go to my next step and I write number 3 and number 3 and I try to figure out what to do next. If you know what to do next, do it. If you don't know what to do next, go through your 5 things. Do I all of a sudden have words showing up here? No. Words did not magically appear. Did symbols magically appear? No. Can I do algebra with this right now? Still no. Substitution or transitive. Do I see the same name popping up multiple places? I do now. So, I start to see the same thing popping up multiple places. I should have told you if you want to grab highlighters, you may. Up to 3 highlighters. If you don't want highlighters, you don't have to use them. They can definitely help in these proofs, but that's just a personal thing. Highlighters are up there if you want them. If you want to grab 3 different colors, go for it. I'm going to pause for a second. Thank you. I appreciate you. Some of you are grabbing them out of your backpack. That works too. Louie, are you awake? Okay. That's the same.
What? Just.
Okay. So, we said there are some things that are the same. What do you notice that is the same? What's showing up twice? First thing that could is KJ. Is KJ on here twice? Yes, it is here and here. JI could show up twice. Is it showing up twice?
Yep.
Yep, it is here and it is here. KI could show up twice. Is KI showing up twice?
Yep.
So, those are the things that are showing up multiple places. Now, that means that I can do either substitution or transitive property, which I do depends upon the problem. Do you want an easy way to know which one you use?
Yeah.
You can always say substitution if it's equal signs. If it's congruent symbols, it has to be transitive property. Are they equal signs or congruent symbols?
Equal.
Equal signs throughout this problem? So we can do substitution. I replace something with what it is equal to. So this KJ, which I underlined with pink, turns into 2x plus 16. Then it says to do plus, and then I come across green, which JI we said was,
X plus 15.
ooh, be careful,
6.
Oh, 6.
6. That's why I underline them. Sometimes I highlight right over them, but in my pen it doesn't work out nicely under the document. Then it equals KI, which is the x plus 15. That was substitution. Remember substitution, SUB all the way to S. Now at this point we can go back through our 5 things if we want, or what do you do when you see stuff like this?
Solve.
You start solving. We've gotten to the algebra. If you recognize it's algebra, do the algebra. I want to solve that. When I solve an equation like that, the first thing I should do is
No.
Combine.
Combine like terms typically. 16 and the 6 go together. I get 2x plus 22 equals x plus 15. Combine like terms is not actually called combine like terms, though. It's simplify. Things like combining like terms are simplify. My next step. Earlier I heard subtract the x. Can I do that now? Yes. Now, remember the minus x. You can do it, but it's not the step. The step is the results of the minusing x. I get x plus 22 equals 15. We just subtracted SUBT. To finish it off, I subtract the 22. That's step 6. I'm subtracting again. And I get x is equal to Here's the nice thing about a proof. A proof will always tell you what the last step should look like. Your goal in the proof is to get this to look exactly like what it says under proof. Does it look the same?
Yes.
Sweet, that means we're done. So, on top of having the given, you should also know what this step always is. Okay, flip the page. We're going to go down to the one that the 3 accidentally got deleted from, but we're going to skip over to. Going to move down to this one. It's a proof, so the first thing I do, draw the bars. Label statements and reasons. S and R is just fine. Every single proof, regardless of the proof, starts with what information?
Given.
The given. So my first reason is the word given. And my first statement is whatever was given to me. SR equals 544 plus 6x. RQ equals 73. SQ equals 8x plus 795. If you are a person who really struggles with lining things up, because your right and left side should line up, you can always draw bars after your steps as well to help you organize. You don't have to, but if that helps, do that. After we get that down, we go through our 5 things to tell us what to go through. First thing is words. Are there words? No. Second thing is symbols. Are there symbols?
Oh, yeah. No.
Symbols like congruent, parallel, or perpendicular? No. There is a bunch of symbols, but they're not the right kind of symbols. Algebra. Not currently. Substitution or transitive property. Do you see something showing up there twice?
Mm-hmm. No.
I heard both yes and no.
Yes. Oh, no.
No. There's an SR, there's an RQ, there's an SQ. Not quite. Is there a picture involved?
No.
Yeah.
Wait, yeah.
The picture doesn't always go here. The picture goes over here, but we can use the picture. These are the 2 things I can get from pictures. Am I do segment addition or angle addition? Segment addition. Seg add post. And it says I can add with the letters.
SR plus RQ.
SR, first part, plus RQ, second part, equals SQ. Full thing. Beautiful. Thank you, Kata. Did words magically appear? Did symbols magically appear?
No.
Can I do algebra now?
Yes. Wait, no.
We don't have a single equation we can do algebra with. Can I do substitution now?
No.
Yes.
Never.
Always. Not always, but. Did SR show up in two places?
Yeah.
If it helps to box in rather than underline, you can do that too. If it helps to just straight up highlight, you could do that too. I've done it both ways. But I've got SR, I've got RQ, and I have SQ. So yes, I can. Am I doing substitution or transitive property? Substitution. When it's equal signs, it can always be substitution. Okay. SR is going to be replaced with 544 plus 6x. Plus RQ can be replaced with
73.
73. SQ can be replaced with
8x plus 795.
8x plus 795. Be careful. They're not always going to go in order. Sometimes they will, sometimes they won't. Words did not appear. Symbols did not appear. Can I do algebra now?
Yes.
Yep, I'm at the algebra step. Mason, if I want to do algebra, what would you tell me to do first? Simplify is the step. Jace, what can I simplify? Are there like terms?
Yeah.
Which ones?
The X, C6X, and that, yeah.
Ooh, but those are on opposite sides of the equal. They have to be on the same side. Are there like terms on the same sides?
The 544
544 and a positive 73. 617. Still plus a 6x, still equal to an 8x, and a plus 795. Lexi, what would you tell me to do next? Do you see there's x's on both sides? How do I get them together? Yeah, minus 6x is what I would prefer. 617 equals 2x plus 795. We don't call it minus, we call it what, y'all? Minus is also known as subtraction, S-U-B-T. Amari, what would you tell me to do next? Subtract 795. Negative 178 is equal to 2x. That was subtract again. Can't call on people who aren't here. Faith, what would you do next? Divide by 2. Now, be careful. You cannot flip-flop sides of the equal sign without it being a step. So it should say negative 89 equals x, not the other way around. Is that what it asked me to prove?
No.
No. Now, had it asked me to prove that x was equal to 89, I would then simply flip things around using what property?
It's YMM.
Symmetric, SYMM. But it didn't ask for that. What did it ask for?
Prove SR.
To prove what SR is. Now, there are 2 more steps in this proof because of that. Here's where writing big can become a problem, and I write big. So, it wanted us to prove what SR was. Here's the thing. We always can plug things back in. Plugging things back in would look like this. I want to prove what SR is. I know that SR is equal to, up here it says it's 544 plus 6x. So I can write 544 plus 6. What's between the 6 and the x?
-89. Wait, what?
Multiplication. So times, or I can put it in parentheses as a times symbol. And that is substituting back in. Plugging back in is substitution. Doing the actual math to figure out what this is, I can do that 100% in a calculator. 544 plus 6 parenthesis negative 89. I get that SR is 10. Is SR supposed to be 10?
Yes.
10. Yeah. That means we did it right. To change from this to this is to simplify because you're following PEMDAS. Is the math in the proofs difficult?
No.
It's tedious, but the math itself is a lot of add, subtract, multiply, divide, substitution. Hey, I've got a worksheet for you. I got worksheets all week. I tried to give you a minimum of a half a page per problem. That way you've got plenty of room to write because some of y'all are like me and write big. There's only 4 on this assignment, yes. Now, with that, if you are someone who writes really big or needs lines, if you want to write on a separate sheet of paper and attach it, you can. If you use your time wisely, you could likely get a good chunk of this worksheet done.